Now, with example 1, we're being asked to estimate the area and give our answer to the nearest square metre. Usually the questions actually say using Simpson's rule. Usually it's pretty easy to identify the sort of question that you're going to use this rule in. I guess the only thing about this is we don't really know much about this curve side. So we would be thinking, oh, we should use an estimation, and our only estimation for area is this rule called Simpson's rule. So even if it wasn't mentioned, maybe you'd know to use it anyway. So what seems to be going on here, we've got and again, we'd approach this just like we approach most problem questions where we identify the information given. You might see clearly the number 7 occurring twice. Then you've got the numbers 10, 8 and 11. Now, if we think about Simpson's rule, Simpson's approximation for the area, is A is equal to H on 3, our first distance, 4 times the middle distance and the last distance. We can see that we've got 3 distances, and hopefully you recognise these as the 3 distances across, measured across this shape. And they're measured at intervals of 7 metres, which becomes our H. So then it's just a matter of subbing into the formula. So it's 7 on 3. First distance is 10. 4 times the middle distance of 8 and 11. That calculation is very simple, really. Please take your calculator and practice. Can't get enough practice of your calculator. Examiners are telling us students still clearly not able to use a calculator by the time they're actually doing the HSC. So I would suggest that every student should be using their calculator. If you're using it every maths lesson and homework between now and the HSC, I'm pretty confident that you will have sorted out any calculator issues. You will have certainly identified them, and if you ask, then you can get it sorted out, and so that by the time it comes to the HSC for you, you'll be using your calculator correctly. You can see here I've pulled up a digital calculator that is probably the most similar one to this would be a Casio, and you can see it actually shows the fraction. It's probably a little bit too late for some of you. You're probably not wanting really to learn a new calculator, but we have been informed that the Casio calculator, students using the Casio calculator are more likely to get the correct answer. And so if you could at all see yourself making the change to a Casio this late, then you would need to be prepared to spend a bit of time learning it. Then I would probably advise you to give it a go. Of course, keep your sharp as well, just in case you don't master this one. The good thing about this calculator is that the fraction work is much easier to do on the calculator. So you can see there that I've fed that in. I've got an answer of 371 on 3 meters squared. You can actually leave your answer there if you like, or write it as 123 2/3 square meters. Now, with example 2, the only thing about it really is it's been drawn with a different orientation, so that it's been turned around. And the other thing is, if you notice, this number here has been given this time. I guess also we've got a 1, 2, 3, 4. Now that's a little bit unusual to be given 4 distances. In the past, we've only needed 3 distances. First distance, middle distance, last distance. Now, what's actually happening here is there is a first distance here. It's actually 0. Now we just have to know that, have to realise that. The 2 becomes a middle distance. The 2.2 becomes a last distance. And that much is one application. You'll probably see where this is going now. There's a second application. And what's happening is this 2.2 is the first distance, the 5 is the middle distance, and the 2.1 is the last distance of the second application. So that's all good. We can see we've got 2 applications, and I'll show you how we set that up. But what's this 8? 8 is the full distance. So certainly the distance between the measurements is not 8. And if you have a look at it, we've got 1, 2, 3, 4 distances. They're equally, 8 is equally divided by 4. A very important thing to register here is that h is equal to 2. 4, 6, 8. And we're doing 2 applications. I'll just pause the video and write up what 2 applications would actually look like. Here I have area is approximately equal to h on 3, a first distance, and 4 times middle distance, last distance. First application there, plus we're going to add on our second application using exactly the same formula, h on 3, first distance, 4 times middle distance, and the last distance. Now that's probably what you'd expect for 2 applications. So let's substitute our values now. H is 2, so it'll be 2 on 3, the first distance for application 1. So we're going from here. Remember, we had to identify that first distance as a 0. It wasn't given. We have to be able to see that. 4 times the middle distance of 2 and the last distance, 2.2, plus second application, h stays the same, 2 on 3. First distance is your 2.2. The middle distance is 5, 4 times 5, and the last distance of 2.1. I'm just going to pause the video and do that calculation. Hopefully I've done that correctly. I'm sure you'll let me know if I haven't. And I'm getting 23 square metres as the estimate. With example 3, clearly there's no diagram given, so I would suggest that the first thing you do is to draw a diagram. So you can see I've highlighted the key information and drawn the diagram. I'm showing my measurements at 6 metre intervals. The measurements are 10, 15, 12, 11 and 8, and I'm going to do 2 applications of Simpson's rule. So identifying that, h is 6. In the first application I can see that first distance, middle distance, last distance, 10, 15, 12. Then second application would start 12, 11, 8. So my approximation for the area, I'll start over here, would be, I'll write the formula just as 2 applications. H on 3 would end up being 6 on 3. The first distance for the first application was 10 plus 4 times the middle distance for the first application is 15, plus, and the last distance was 12, plus second application, still H is 6. The first distance on the second application is at 12, 4 times 11 plus an 8. Now I'll just pause the video and do the calculation. I haven't made a mistake there, but please use your calculator and check to see if you get that value, and if you don't, then please let me know. We'll check it. I'll check it with you in class. You should then be able to do exercise 304.